Good evening, everybody. So this is Narendra. Today I'll be sharing my experiences on the Docker Demystified. And let me share my screen first. Let me share my presentation. And hopefully everybody can see my screen, right? Can anybody give me a thumbs up? My presentation? Yes. Okay. Thank you. Thank you for the confirmation. So let me share my slides actually. Yeah. So thanks a lot for the joining. So first of all, before even starting the session, I would like to say a few words about DevOps Artisan. And I would like to thank Elena, Dan, and the team behind this one, putting together this particular session. Actually, I'm really motivated to work with them, actually. And I would like to share my experiences on the Docker Demystified, actually. So I'm CTO, so I'm Narendra Babu, so I'm CTO. So I worked in New York for last 12 years, working for largest fintech companies like Bloomberg, BlackRock, and Hewlett-Packard in the Wall Street. And today's agenda would be more towards on, I'll be sharing my experiences on how Docker was helpful in my organization, what kind of problems it solved for me, and what are the learnings I learned in New York working with actually the Docker committers. So I had a great experience working with the actual people who created the Docker, Jerome Petnogy and Solomon Hykes and other people who are actually committers. And based on that one, I'll share about the Docker community experience. And these are common questions people ask: where should I start Docker? Where should I start learning about Docker? Where are the things I can learn from online resources, offline resources? How do I get up to speed on what is happening in the Docker world? That's one of the things. And industry learnings from my experience, from my background. What are the engineering things I learned about the Docker? And what is the behind the scenes of Docker, what happens behind the scenes. So I'll talk about the package management, how it is related to Docker, and I talk about the VMs versus Docker containers, which everybody talks. And I will share some my viewpoint on how people need to think when they talk about the Docker thing. And we talk about the problem statement. That is one of the important things from an engineering perspective, why Docker is in the first place, right? Everybody's so much passionate about learning about Docker, passionate about implementing on Kubernetes, passionate. It's all about how do I containers is ruling the world. I'm going to share those experiences, and I talk about the Docker internals, about C groups and namespaces, how these are related to the Docker. So one thing, disclaimer, I want to make sure that one is, this is purely a technical session, and it's purely about what is Docker internals, what happens behind the scenes, and C groups, namespaces, package management. These are the topics which I'm going to cover, rather than how are you going to use Docker. So that's a different session altogether. This is all about what happens behind the scenes Docker, why Docker was born, how people need to think, what kind of problem Docker solves. That's the goal of this entire session. Not about how to use a Docker, how to implement in production. Those will be coming in the next sessions. But this is corely focused on engineering stuff, low-level stuff, behind the scenes stuff. Right? So this is what I look up, any particular technology I learned in my experiences, past experiences, whatever it is, whatever tools I learned, I always look back, what is the problem it solves? And do I really understand the problem in the first place? And then I formulate the problem, okay, this is what the actual problem it solves. Then it should be really, really enjoyable experience for me. Then only I can be really giving justice to the tool or justice to the product which I'm learning. Until I don't understand what the problem it solves, just because somebody says it, it's not going to help me out to grow in that particular technology. And that's one of the things which I always keep in pride, saying that anything I touch, I should be knowing these three things. What is the problem it solves and where it started? And it should be really, really challenging and interesting to learn for me. Something I can learn out of that one, which I never did it. Everything is on GitHub. So I have a GitHub URL I can share with you. You can play around with the Docker. That has more than what I'm going to talk about today, actually. And one of the core requirements for these labs, what I'm going to do is it's Ubuntu 1804 or greater than this one. So, or GNU Linux, or you can use your cloud environments wherever it is. Ubuntu would be the standard one, which I use always, actually. And unique learning experience, what I did in the Wall Street from New York, actually. And be patient. And one by one, we'll talk about the internals of that one. So this is my overall, in a nutshell, what I did in my last 2 decades of experience in software and infrastructure experience. And recent past, for 12 years, I work for Bloomberg, BlackRock, largest asset management company, handling $7 trillion worth of asset, and how I solved the CI/CD and the Docker related problems which I faced in BlackRock. And currently I'm a CTO, Chief Architect for Chief Architect for Foxolabs, and I'm more on Docker and Kubernetes consulting in this region. I did different roles, software engineer. Still, I take a pride. I'm an engineer. I love to be in engineering. I love to be solving problems, engineering problems most of the time. And I was DevOps Architect, VP, pre-sales. So everything in a nutshell, I was doing every kind of role in this 20 years. I got every opportunity and explored every opportunity, enjoyed every opportunity what I got. This is the background, so technical background. So it's purely everything related to Docker. In the sense, I used to work on HP Unix, Sun, SCO, AIX, DEC. So you can think about any Unix for last 2 decades. I enjoyed before Linux. That is what the core platform I used to work for business applications for different kinds of customers, mostly on C++, starting from compilers to the build systems, at the system tracers, Ltrace to strace to ptrace. Compilers, I enjoy compilers. I can talk about compilers for the whole day. That's my favorite topic, actually, linkers and profilers, debuggers in different platforms. Now you can understand that one. That is what my core expertise on low-level things, C++ at the kernel level. That's what I spent most of my time, 2 years of my time. And containers, Docker, Kubernetes are next step of my career because of this past experiences. And this is at the high level I can talk about. So I built my own kernel 15 years back. I build my own compilers, and I don't download any packages. I'll talk about that one, how Docker solves those kind of problems. And I always build from sources, then apt-get yum install. That's the next stage of building and installing your packages on your Linux operating systems. Mostly, I care about simplicity. The product should be simple. The product should be performant and high availability, because these are all the requirements for my fintech customers when I dealt with my employers and my companies, which we need these kind of things to deal with problems which we deal in our day-to-day life. And everything should be productive and passion for troubleshooting. We'll be touching a lot of troubleshooting issues. Couple of things I'll share today, how the troubleshooting works. And that's the only way to learn about any technology, by fixing issues. That's one of the things which I learned. And working with collaboration, that's one of the important things which I always share with people. It's not that using the tool or using a technology will make you beneficial. You should be part of the community, and you should be learned with the community, because anything on open source, without open source, nothing is possible nowadays. So you should be part of the community, and you should be contributing, learning with the community, fixing the problems, and experience about what is happening latest and greatest in the Docker world or Kubernetes world or any technology which you work on. And I always love about CPU, memory, and Linux operating system. So this is where I always tell people when they want, this should be the last slide, but I always ensure that it is the first slide. It should not be in a reference slide where people can ignore it kind of things. Okay, these are the learning resources. You can go ahead and start learning that one. Most of the people will just ignore it. So I thought that let me put it in a first slides. So first thing you should start is the awesome Docker. That's the word you should search on GitHub. That will list out all the Docker related projects on the planet Earth on the GitHub. Right, that's the place you need to start. What kind of projects are happening, lively happening, and what things you can learn from networking, storage, Docker-related compose, and every kind of ecosystem surrounding Docker. That's the way to start. And people need to learn about Linux kernel. If they don't know, at least start learning about basic things about Linux kernel, how Linux operating system works, how CPU works, how RAM works, how this process management works, memory management works, and IO thing works. Compilers, yes, that's my favorite. And I would like to advise also, look at these compilers. So these are the stable products. And this is where stability, performance, reliability comes into place. These are the things which behind the scenes makes your Linux more stable, more robust, and more reliable. So be part of the community. These are the things: GitHub, Slacks, join the meetups, join the Linux users groups, join the conferences, Stack Overflow. These are the places where you need to actively spend. And these are the URLs people need to spend on this GitHub URLs, where you need to look at the issues, what is happening with the Docker, and what kind of issues people are facing. Are you facing the same issues? Can you reproduce the issue? Can you contribute to that issue? Can you fix that issue? Can you at least understand what is happening? That's how you become a better engineer. And this is the goal of become a better engineer, is not by using the tool. It's about part of the community, looking at the issues, what is happening actively in the Docker community. And this is how you keep up to date. And DockerCon, that's where the real engineers come and share about their experiences about the problems. And I was very active when I was in New York, going to these conferences and talking to the like-minded engineers, and actually real problems, what they solved, and I can learn from them. I can share about my problems, what they can learn from them. So that's one way to keep up to date with the technology and be part of the community. And this is one of the things online. I don't want to install Docker in my machine. I don't have a Linux machine. At least you can start getting up to date or getting started with these online resources. So you have this online on a click of a button. It will open a browser with a Linux terminal, and there will be clear instructions, and you can run those instructions and play around with the Docker to get started. You don't need to install if you don't want to install, if you have Windows machine or something like that. But I always advise you need to have a Linux installation. Then only you can be very much motivated to learn by doing the real things. Okay, so now let's start with the Google experience. So this is one of the things which I always start with the Docker or containers in general. So almost everything at Google runs in containers. So if people are aware that Google has many products, Gmail, web search, YouTube, Maps, and any product you name them, right? So it's all runs in containers. And containers, Google has innovated this one in 2003 itself. And I'll share you why. From C groups and namespaces, they are the first pioneers. From 2003, they are trying containers. That's not a Docker containers, but that's something related to Google related problems. And they are similar to containers. And now you can think about, they launch billions of containers every week. And that's an unimaginable scale. It could be more than billions also as we speak. And everything, even their virtual machine run in a container. If you look at your Gmail, whenever you log into Gmail, if you see loading there, that clearly implies that they are spinning a virtual machine there. That's not loading of slow performance or something. It is loading behind the scenes. It's actually spinning up a virtual machine. It's actually spinning up multiple virtual machines for maintaining high availability pods in a Kubernetes terminology. And these are the products which everything runs on containers. And why containers are so successful? Because of it is self-contained. It's very easy to package the applications, and it can run in any other platforms also. Whatever you do on a dev, TST production, the packaging of Linux containers will be always the same. How those things are achieved through C groups and namespaces, I'm going to share with some labs how the containers exist in the first place. Because of its low overhead, its spin up of containers very, very fast, and why we are going to learn from how do we compare with virtual machine to the containers, and how easy it is to compose containers, how easy it is to manage dependencies with the Docker, and easy to replace. Like it's not like a virtual machine you need to spin up. It will take a couple of minutes for that one, and getting a VM up and running is not a fun activity when you need a high availability. When you need high availability all the time, you need to have a very faster to respond to the event, and it should be out of the box. It should be seamless experience for the user. User should never ever see there is something gone wrong. So that's where the containers help in very much into the making high availability, spinning of containers on the Kubernetes. That is the container orchestration system, which is pretty much hot or pretty much in need in this current world if you want to run containers. And this is what containers open doors for innovation. That's as simple as that. Anything you touch now is running containers behind the scenes. You talk about any technology, you talk about function as a service, CI/CD, DevOps 2.0, cloud native applications. You want to think about portability, scalability, reliability. You talk about data science, artificial intelligence, anything behind the scenes, containers are the source of these things to scale up, scale down, high availability, performance, everything you name about portability, running at the scale, everything behind the scenes, containers. Containers are running the show behind the scenes to achieve high availability, reliability, stability, performance. You talk about anything, microservices, Kubeflow, and putting human to Mars. Nothing, it's not far away. So everything behind the scenes, it runs behind the container, all your tech stack. So this is where actually we start with actually understanding why Docker in the first place. Rather than jumping, Docker solves this container problem. Docker is the self-contained. It's well for package management. It's well for running in different environments. Spinning up is very easy, performant. This is where I look up to people. If you are thinking about Docker from a development background, end of the day, you should talk about only dependency management. If you think about C++, you should talk about shared and static libraries. If you think about Node, your package management is done by NPM. That is where your third-party library sits there. If you're talking about Python, it's a pip. And if you're talking about Java, it's a Maven. For other technologies, you can look at the respective dependencies. But whenever you talk about dependency management, people need to start from this one. They need to understand what the dependencies are. You can build your applications, but end of the day, you deal with your libraries. That libraries are coming from open source. That can be commercial, anything, but nowadays it's mostly open source. And you need to make, in order to run an application in a production, you need to have your application, and at the nutshell, you need to have your dependencies also. And you need to club this one to make a package, and plus operating system features, right? It's like a tiny Linux plus your application, plus your dependencies, plus your environment. That makes your Docker container. If people miss this point just by looking at a Docker file, looking at the dependencies and all, you lose the focus on that one. So that's all, always insist people to understand your dependencies, understand your package dependencies. And if you understand your package dependencies, you are very near to understand what Docker solves the problem. Right? Previously, if you don't have dependency issues in a production, if you don't have environment issues in a production, if you don't have port issues in a production, if you don't have any upgrade of OS happens and it affects your application to the production outage, and that means that you understood these kind of problems have gone through in the past pre-Docker era. Now you'll appreciate that one. Just because I have those kind of problems, environment issues, dependency issues, operating system issues, any upgrade happens, why my application should go down just because operating system got upgraded? Because it's dependencies, because every application have its own dependencies, and you need to have multi-tenancy, in the sense 5 different applications running on a single server. If one application uses different dependencies, another application uses different dependencies. If you upgrade, mix and match with the dependencies, you have a hell lot of problem. So that's where Docker helps into this in this scenario, how to handle those dependency management to the Docker file. Right, I'll share with an example on that one. And one more thing, apart from the dependencies, you need to even understand how this package management works in Linux. These are the 2 important things to have an entry point into Docker. To understand Docker, these are very, very important to understand how this package, how do I install a software in Linux world, GNU Linux world. In Ubuntu or Debian versions, we use apt or dpackage. That's how we install any software in the Ubuntu world and or Debian world. And if you take about CentOS, Fedora, Red Hat, that's one more distribution from for the Linux distribution, and we use yum to install it. And if you want to understand the differences, you can go and look at the DigitalOcean stuff where they talk about the differences between that one. But at least you need to know what are the package management available there, which operating system I'm using it, how do I install a package from their repositories. That's as simple as that. If I want to install any Redis package, how do I install it? And this is where through operating system calls, operating system package management tools, I use that one. Now let's work with the workshop. This is the first workshop which I want to share. If you understand, this is the whole crux of Docker. And I can share my personal experience, that one I never seen anybody explained in any of the YouTubes, nor any of the blogs, nor the Docker guys itself explained in a proper way what kind of problem they solved. They just jumped into one problem, they tried to solve it. The engineers understand that one, but it was not presented in a very easily understandable with the people, right? So if people want to understand, looking back, where the problem was there, and what are the difficulties I'm facing before Docker, and what are the things Docker has helped me to solve those problems. Because I lived with this one for a long, long time, and many of the Linux engineers, many of the core engineers who are 10 years, 15 years before that one, this is what they used to do. And they can really appreciate, okay, this is what Docker has solved me the problem. Now I'll talk about 3 steps from 0, 1, 2, 3. So in the sense that one, in order to achieve Docker, you need to cross 0, 1, 2. If you understand the problems at the 0, and if you understand the problems at the 1, if you understand the problems at 2, you understood what is 3. 3 is nothing but Docker here. So let me talk about, I want to install Redis in my operating system. That's my goal, Linux operating system. What is the best way, or what is the, before a decade, before 15 years, before 20 years, how we used to do? This is what you used to do. You go to Redis website, and I go and look at any package, and I used to do million times these things for other packages and all. And I go and look at, okay, this is the way I need to download the sources. In a nutshell, how do I do Redis installation 10 years back, 15 years back, when the open source package was there? I need to go to that website, FTP server. This is at least beautiful to see the website, very cleanly instructions. Previously, it was just an FTP server, you get a tar file. And the regular way, you get a tar file, untar it, make install, make test, make install. That's the way to install Redis. Now I'll run the first step. Just focus on that one. So I need to download this one, wget. Already I downloaded it, and untar it, and I already untarred it. And I'm going to run in this cd Redis, whatever my package. So I installed 609. So this is my Redis installation. I'm just going to share my terminal. Okay. Now this is where I untarred that file. So I'm gonna build that Redis server. My goal is my developer comes and asks, or I'm engineer, I want to work with Redis. Redis is a NoSQL database. If people are not aware of that one, it's just a NoSQL distributed database, and it's more towards a key value database. That's all. It is majoritarily used for caching. So whatever you do, web related programming use behind the scenes for caching. Think like it's a key value database. That's all you can think about data store. And this is what I did for more than a decade. If I want to install any package on Linux, yes, it's a tedious. Now you can understand what is going behind the scenes, how much time it takes, and you need to understand the build systems. You need to understand the compilers. You need to understand the make system. If anything failure happens, you need to go and fix those issues. That's what I was doing. And I know the pain, but I enjoyed the experience because it's a Linux thing. You learn a lot by fixing issues. And now you can see just 1 minute it took me, 30 seconds it took me to that one. Now I will just run something test here, but it will take time. But I will just show what I did. That's it, nothing more than that. So after that, I do make install. There are certain situations who are Linux guys. There is a configure before this one also. I don't want to complicate much on those things. There was a configure which actually evaluates your environment, whether libraries are present, whether the compilers are present, whether the right set of environments are present, right set of tools are present in order to build this Redis package. So that was configure, and you can pass on your compilers, you can pass in your configurations and everything. But I just moved it to one step ahead. So just to make install that one. So you set up your environment through configure. It will read up the compilers. It will set up before even installing Redis. It has to just evaluate that whether in order to run or build Redis, I need to have this kind of compilers, linkers, loaders, libraries, system libraries. If those things are not there, what is the point in failing at the 10th stage or 100th stage? I should better fail at the first stage when something is not there. That is what configure is to do. That generates a make files, and you run your make command on that one. So make file is just a, what should I say? It just builds your software with handling the dependencies. Right now, I'm doing testing. Before I install Redis, first step I did was just I built a Redis server and a Redis CLI. 2 binaries are built now. That is what I needed for Redis. Now after that, I need to even test that Redis CLI, Redis server, whichever I built the software in my Linux operating system. I need to test it out whether those things are actually working. These are unit tests for actually running Redis itself. So I want to cancel this one just to show what is the process here. Now that testing will go. It will take at least 2 to 3 minutes. Think about multiply with 100 packages, how much time I would have involved. So why I'm showing this one is, this is what the time is involved. This is what the effort is involved. Anything can go wrong. You do again, read again, look for the issues, look for fixing the issues. Now you'll understand step by step how Docker solves this problem. See, think still it is running. And I've seen thousands of packages having problems, compiler issues, linker issues, dependency issues, lots of issues. That's how you fix it, the problems one by one. But that's a time and money involved there in terms of fixing those issues. I'm just canceling it. Assume that one I tested it, everything fine. Now I will go and look at where is my binary got installed. I'll follow the instructions. I'll just follow the instructions, what any particular website says about that product. I did the make. Now that he says that one, okay, you did the make, he didn't mention the test, that's okay. And this is how you run your server in your local installation. This is my local. You can clearly see this one. It's no magic here, and it is in my home directory. It's not anywhere. It's just home Babu CH. That is my home directory, and I'm going to run my Redis server here. Voila! I just run my Redis server up and running. Just I downloaded the tar file, untar the file, make test it, and it has installed that in that particular directory. Now Redis is running now. This is what proof of that one. Redis is running. Now I need to run Redis CLI. Follow the instructions again. Just follow the instructions, what he has mentioned. Voila. So I got the first command I always run in the Redis, as I told, it's a key value database. The first command is ping pong, in the sense, actually I ping that server is available or not. The server is available for me, and it is listening on 127.0.0.1. That is my local host, and listening on the port 6379. Right now I will set given. This is what I'm setting. I'm inserting the data values here, right? Now DevOps Artisan, that is what I want to say, right? So I'm putting this one and get the name. That's what it is. So keys, there are a lot of things about your info about your server. So all the commands. Now my goal is to just to install a Redis server and look at the commands and play around with the commands. My job is done here. In the sense, the basic source installation of Redis is completed. If people can understand, that's the first step of understanding what is the problem Docker is solving here, right? So I'll show you one more command here. So let me go and look at to just show it. Redis commander. That is one of the UI tools. If people like UI, current generation likes a lot of UI stuff. And this is where get name. I'm just typing it what I just had it. That's the only thing to think about it, right? So I'm just setting a name. See, this is whatever, just keys, it should be keys. Sorry. Get name. You can easily look at what are the changes I did it here. Name Babu. I'm setting it here. I'm getting name Babu here. And I'm gonna go and check here, whatever the day I'll get the name here again. Babu. So that's what I replaced that one. So it shows that one I have installed Redis in my system. I validated through UI and I validated through my command line. Now let's go to the next step. So after this one, this is 0. Let's go to the first step, right? So I installed Redis through command line. I solved the problem of installing a Redis, putting some data into Redis and looking at the UI. I'm canceling my Redis server. Now you can look at, if I start a commander, it will show an error saying that one, your Redis is not connected. So just because I canceled it, right? So that's the first step. So I'll cancel that Redis commander. Now I'm going to the next step. Let me go to the home directory so that people can have a clear idea. I'm running from everywhere. So what is the next step of this one? Of my learning experience of Redis is how do I install through package management? That's my command line here, right? So now that step is a tedious, and for thousands of packages, I can't do that one. I can do for my packages. I can do for what my company needs. Those are all perfectly fine. I can tune it. I can optimize it. That's the reason I do buy from the sources is it's optimizing for me. I control everything sources. I don't depend on operating system, nor a distributor, nor a Docker to validate, because I work in a fintech companies. We need to audit everything. It comes into your company, open source or non-open source. I used to already audit those things in my firm, and I need to validate with my compilers. I look at my compiler flags. I look at my optimization. We love performance. So you optimize from the source. That is how I do it. Now, the next step is what the distribution provides. Now I'm depending on Ubuntu to help me out to install Redis in this one. Now, I'll just once again. So apart from sources, the second way of installation. Now, no, Narendra, it's very painful for me to install to make. I don't know make. I don't know make install. I don't know compilers. I don't know Linux. I want to just install to operating system. Yeah, let's go to the next step. Operating system has those packages, right? So sudo, this is one way to install. This is next way to install. App install Redis server. If it has already installed, it will say I already installed it. So I play with a lot of things. So let's see. Password. So this is it has installed. So it says already installed. So I'll show it to you one more time. So better to show you because I do a lot of experiments in this laptop. So I remove this Redis server. So it says that one, it is removing Redis server here. So I want to show it to you how the operating system installation works, right? Previously I showed how to build from sources. Now how operating system does the job. So I'm installing Redis. This is how sudo apt-get package management works on Ubuntu. You will be doing yum install, you'll be doing dnf in Fedora, and respective package management for respective Linux distributions. So voila, I just installed my Redis server here. So how do I validate it? I will go and look at the Linux commands here. I will look at whether the Redis server is running or not. So this is the service because it's operating system related things. Operating system has installed it and it has started the server. So how do I validate it? Through status. Service status. That's where I validate. Now you can see it is a service which is running in the operating system. As simple as that. And now how do I validate on a ps-ef get Redis? Because I didn't started it. It's Redis has started it. It's operating system command. So Redis, and that's the port you always look for it. Now immediately, as I told, I'll be running Redis CLI because server is running. Previously I started a server, then the client, then the Redis commander, right? Now I'm running directly the CLI thing from which is connecting to my local Redis installation, which is done through apt-get install. Now again, I'll be running through Redis commander. Sorry, typo. Sorry, it's responding a little bit slow. So yeah, so that's the way I opened a CLI. My Redis server is running. Now I have a CLI. The first command I always run is, as I told, ping pong. Yes, that's where the server is getting pinged up. Now again, I'll set some name, right? Name or country. Let me put it this way, country. Okay, India. So let's assume this one. This is the thing which I want setting, right? So city. If I want to city, if I want to set some city here, I'm just playing with some data. That's it. New York. That's my favorite place. So that's what I'm getting that one. So get, instead of get, I'll use just the keys command pattern. So it shows me what are the things are there. Now again, I'll go and look at my Redis commander. So to look at what are the things are there. So just now I entered in front of you and I have city and country here, right? So that's the only thing. And info, same thing for the server related information. Anything related to server, I'll get in this place. So it's just showed that one apart from sources. Now I did through apt-get install also. Let's go and look at what is the difference between here. So what did I did here? So I'm just exiting again. So job done. So I installed Redis through operating system package management. And now I'm happy to install it very easily. No make install, no make test, and no looking at the source directory. When you go to production, you need to set the paths to do that one. So what is the difference between these two things? First thing with the sources, second one through the Ubuntu package management system. So first one is actually I made my local system dirty. Dirty in the sense I can't reproduce this one. See, all the things are here. Redis. So it is in my local path. I can't, what do you call? Sorry. I can't share this one to anybody else, right? So you can see here Redis server here. You can see Redis Sentinel. These are all the software I installed it, but I cannot share with other team members. I can't share with other people. If I change a compiler flag here, if I optimize something, I cannot change the same thing. I can change a binary through FTP and all, but that's not efficient. And it's very, very painful to share this software to other people, other teams. So I had to do it manually. I had to do using some scripts, which I used to do for a long, long time. And the second process is now, if you look at, that's the first thing. The second one, which I installed through my operating system. Redis. I want to know where did I install? So that's the place I installed it. Now, again, it's not reproducible. If something goes wrong in the operating system, if server crashes, if anything happens with this file system, I'm doomed. I cannot reproduce this one. And that's two challenges which I have is it cannot be reproducible. It is always tied up to my operating system. I cannot share with other people. It tied up to my particular operating. Those are the two challenges which I have now. Because I did it in my operating system. I'm enjoying my experience. Tomorrow my laptop crashes. Again, I need to redo the job. And that's a painful experience. And I've done it tons of time, those things. If I lose something, again, we need to document. We need to play around with that one. Think about real production and multiply it hundreds of packages. So that's where the real challenges of handling a package which you install. And this is only a Redis. I talk about applications, which are C, C++, Python, Java applications. What if those things goes wrong, right? And I can't have a reproducibility. I can't share with anybody else. And the problem is it is tied up to a local file system. If that directory is gone, somebody has removed some permissions, somebody changed something, I'm out. In the sense, there is an outage, there is a problem with Redis, there is a problem with the installation wherever I installed it. And due to some reason, it got me some problems with my application, which is to deal with this one, it got crashed. That's what two things we need to understand. Right now, let's move to the next step, right? So next step, how do I solve with the Docker? Now, the biggest after that one, Docker came into place. As I told, I did this one for hundreds and thousands of packages throughout the years, make, install, and configure. Now I'm going to Docker, how Docker can make my life 10 times easier. Now I see neither I'm installing it, I'm doing it just a command, just a small command. That's it. Don't worry about the internals of this one. Don't worry about what is happening. All my goal and end user goal is to just to run Redis, as simple as that. I need to store some values. I need to see some values in that one. And I can use any other language to interact with Redis. That's a different story, right? All I do is Docker run -name Redis here, right? So that's what it is. I'll run on the top, Docker PS, right? So it actually shows me 9 seconds ago, it just ran the Redis server here. Previously from the sources, then the apt-get. Now I am upgraded to the Docker world. Neither I installed it, neither I built it, neither I'm looking at the right path. And there, neither I'm going to think about where is my Redis CLI here? Where is This is not the path it is picking from because it's a container now. Now I want to just log in one more time. I want to just because it is running in a container. Now I want to see, sorry, it's slow responding. Okay, I want to log into this response, right? So Docker, that is what I want to log on into. I want to access Redis. That's the goal here, right? So this is the command, Docker exec my IT, and I'll put in this container. That's an interactive mode actually. And I'll be launching this one through bash command if it has a bash. So it has a bash, right? So it's like a tiny Linux operating system, as I told. It comes with Redis image. This is a Redis image I just pulled from the Docker Hub. Think image is like a tar file. You just untard it. It does automatically. Docker takes care of that one, and it runs for you. It creates an instance. So whenever I compare image with a Docker container, means image is in an object-oriented language. Think image is a class, container is an object. That's it, instantiation of an image. So image is just stored somewhere else in a Docker Hub, in your case, and somebody's using the Docker Hub as a platform, as a service, and I can download that image, or I can pull that image in a Docker terminology. Then I can start running Redis for here. So again, Redis CLI, say ping set name Docker. Sorry, get name, it will be doc. So whatever it is, so it's just the key value pair. Just want to show that one, and these are all statistics for that one. Just want to show how easy it is with a one line of command. Neither I need to know sudo apt-get install, neither I need to do make install, neither I need to install here. And this is where the portability exists here. Now, any changes I can do, I can just push it to the Docker Hub. From there, I can share it to anybody. So that is what Docker solves the problem of package management. And that is what people need to think about it. Whenever you're using Docker, running commands is one part of the job. Using compose files, using Dockers in production, building Docker files is one part. First of all, people need to understand what kind of problem it has solved in the first place. Just jumping into running commands is one part of the game, but understanding what problem it has solved will make you much more engineering experience. That is what I look up to always. I look up to how the engineering problem it has solved. That's the voila or a wow or a eureka moment for me when I dealt with package management for so long. Oh my God, Docker has solved so efficiently this kind of problem. Right now, you can think about, I didn't install anywhere. It's portable, as simple as that. No installation, there is an image storage and all. But as a problem solving, like coming from a sources, coming from a package management, coming to the Docker, I didn't install anything here. For a user, it's all he has run is Docker run. Docker pull, Docker run will take care of the pull command. And all he has done is the below command here is Docker run command. That's it. Docker run, Redis, read the Docker take care of how to pull the image, where to get the images, and download it and start running it. That's it. And that's the power of Docker here. And think about if I have to install Redis, Cassandra, any databases, NoSQL databases, any package management, think about hours together. I'm fixing that sources, and even I can't replicate that one to other environments, right? And the package management, how much time it will take to actually manage those, integrating those packages. Now Docker, I did not worry about anything. It is not going to spoil my operating system. If this container crashes, it will crash by itself. It is not going to stop anything which is running in my operating system. If you look at my operating system, what is the process is running here? These are my htop is a command which you can, it's like a think in a Windows parlance, it's like a task manager. These are my processes running at any point of time in my operating system. If I did Redis CLI, Redis through package management, though they are just like a process, they can consume more memory. I can add up much more load to my application Redis, which I installed through sources or which I installed through package management. That can consume more memory, more CPU, and it can cause my entire operating system to crash. With the Docker, it's not going to happen. How do you going to happen? Through C groups and namespaces. I'm going to share with that one. Because Docker, again, this is just like a process, but Docker controls the process. As I told, that is where Docker shines here is with the C groups and namespaces. Now, we'll see to the next level. Now, that is a problem which I solved with the Docker with no need of installation. You just run out of the box. That's the problem which Docker solves. So going back to the Docker file. So this is one more step, right? This is one step installation. Again, there is no, there is a reproducibility here. There is a package management very effectively managed by the Docker here. because I'm not doing any package management stuff here. And it is easily shareable. Thus, the dependency management is taken by Docker. Now, what if I want to change the configure of, I want to build Docker for my Redis itself. I want to have my own configurations. I want to build my own configurations, and I want to have base image of my own company's related information. I don't need everything what Redis provides. Maybe I don't need all the things what binaries comes into place. How do I build Redis with the Docker file itself, right? Behind the scenes, Redis team, Redis open source community has created the Docker file. They build the Docker file, adding those dependencies. Then they push to the Docker hub. That is where the priority one for Redis. That's where the majority community who holds the responsibility of owning that project, right? They have the ownership of that one. And they are the people from rest of the world will just pull from that one because they are the authority to what you call to manage that repository for them. So how do you look at that one? So you go out here, Docker hub. Just I pulled it from here. Just what I did, Docker run is nothing but it's pulling plus it's actually running my application. So who is the source here? And these are the guys who are source for me. And this is the place I trust for it. Redis, pull Redis, right? This is the commands and they respectively, they explain about the architectures, which architecture it supports. Now you think about so many dependencies, so many versions, so many versions, so many architectures everywhere, 6.2, 602, 502. Depending on your versions, depending on your application using right set of versions, this is where the dependencies Docker solves the problem. And it explains what are the architectures it provides. It explains where it has been pulled out, what is the Docker file, security related, all related to Redis. Docker Hub has all the information. This is a source of truth for Redis to me. If I look at any other Cassandra, NoSQL databases and all those things, there I go and look at who is the community behind that one. He is the actual people. Then I play around with the Redis. So that's where I look up to Redis whenever I use Docker, means this is where I'm pulling here. Now, next step is looking at the Docker file. So what does this Redis Docker file looks like, right? So in a nutshell, what I did on the sources, let me go and look at the Docker file. So this is the nutshell. This is what the Docker file looks for Redis. See, clearly, I just built it. I wrote my own Docker file. I say that one, pull the base image from 2004. That's my operating system I'm picking up. And I'm running some apt-get commands, update that operating system with the latest packages. And I'm installing some tools to build the Redis itself, wget, because I need to pull the tar file, then the make to make the application what I did, the source level, and build essentials for the compilers. In order to build, because Redis is written in C language and it requires make. And it requires GCC compilers, and that is CC compilers, any compiler you think about in terms of C and C++, right? Mostly C, right? Then what I'm doing here is I'm creating a directory inside the container. When I build this image, should happen. At the end of the day, my Redis should be up and running after the Docker file has created. In the sense when I run it, kind of, this is image, right? It's a high level you can understand. I'm downloading the image, I'm untarring the image, I'm doing the build the image, test the image, and a little bit configuration related stuff and all. If I need it, I can do it out of the box. And what I'm doing, I'm creating a data volume. This is where, as I told, Redis is a database. And where should it store the data? Persisted data. It's in-memory database, but it has to persist some data on the hard disk, right? So that is where I mount from the local host to my Redis container in the containers world. And this is my working directory. And this is where my Redis server, I start, expose the port 63C79. That's my server name. Read this configuration file. That's all. That's all a Docker file look like, right? That's all. In order to build a Redis, this is what I need to do to build. Now you can map to your applications. You can map to any other packages. Just at a high level, this is what you do. And for other play, whenever you read some Docker file, you will understand how these things run. So I want to show one command before I run to the other labs because I'm running out of time, right? So I want to show other things. So because I know this is a lot of things I want to share, but one by one, I will share one by one case study. So as I told, through Docker file, this is where you run it. All I do is go to this place, Docker 101, Redis case study, right? And I have a Docker file. So how do I build the Docker file? Docker build -t prodoc, that is my user ID for Docker Hub, prodoc 0. And Redis version 3. Let's put it 3.0 or something. If it's already built, it will say it is already built. So prodoc 0 build -t dot. Okay, let me put it this one dot. Right, so it has built. So now what I will do, Docker push prodoc doc 0 redis colon. Just I changed something, I built it. Now I'm pushing that one to my repository. Now this is our, I pushed my image, which I built locally, to the repository so that everybody who is available, who has access to the Docker Hub, and I put it as a public, and they can look at that Docker, my Redis version, and they can take that Redis and play around with that one. This is how I share my application to the other world. To my team or respective, I can showcase my talent, I can showcase my changes, I can share with other people. Just to nutshell, that's it. And the next version is Docker Compose. You put the same thing in a compose file just to get a nutshell of that one. But important thing which I want to run because I'm running out of time. So this is what at the high level Linux operating system will look like, right? So anytime you deal with Linux, as I told, we are dealing with C groups and namespaces. And this is what people need to understand, how Docker was so successful, how Google was successful. This is contributed by Google. C groups and namespaces around 2003, they contributed to the Linux kernel. And that is what, after 10 years, Docker leveraged that one. But Google was using for last 15 years. They are pioneers in the C groups and namespaces, and they are pioneers in containers in their own proprietary way. So any hard operating system job is to just manage resources. What is the resources here? Memory, CPU, hard disk, network. That's all the 4 resources we have. And multiple people running on the operating system, multiple applications running on that particular operating system. And kernel, that is what we call it in Linux. It's an operating system which manages the resources across all the applications, efficiently manage the resources. That's the goal of kernel. And the user space, that is where your applications runs, right? So it has to talk to kernel. Kernel is the boss who decides who goes where, how much memory, how much CPU you can run. And sometimes people can take away more CPU, more RAM, reduce the load, increase the load. So whatever it is happening, increase the load and causing other people to crash. Now let's see how Kubernetes, how Docker solves this one. This is in a nutshell. When I look at an operating system, this is what I look at, the low level things. This is the performance observability tools. Just I gave it for a hint, saying that one, how many layers are there in the operating system? Each layer, how many tools are there to monitor, debug, tracing, everything, how an application flows from application to system library, to system calls, to the file system, to the networking, to the scheduler, to virtual memory, down the layer to device driver, which is actually IO controller, but is a disk. If it's a network, means it's a network interface. And all the tools corresponding to that interface. Now, this is at the high level, but I will talk about what are the containers in 2 minutes, actually, in terms of virtual, in terms of developer, in terms of an IT guy, ops guy. Let me put it this way. It depends on who you ask, kind of things. For a developer, all he cares about is, that's what I talked about, application package management with its dependencies. And it's easily deployed in different kinds of environments. As I told, once somebody upgrades an operating system, upgrades a configuration, upgrades everything, everybody, that application can crash because it doesn't know what are the changes somebody has done for those configuration, which it might be depending on, but he didn't change it, somebody has changed it. So those discrepancies between dev, TST, production, that's what the common example or a common use case for last 15 years. Yeah, you might be hearing, it doesn't happen in my dev environment. Only it happens in production environment. It happens in TST because the environments are changing. Developed operating systems are changing. Many people are working behind the scenes, upgrading the stuff, handling the dependencies, changing the configuration, thinking that he's the only guy who's changing that one. And that is causing crashes, that is causing, because you don't have anywhere to have portability across your applications. You depend on operating system, file systems. When you talk to infrastructure guy, he talks that one, it's a shared kernel. He talks about, I need Docker containers which can run on the same operating system. I don't need, even if I change the operating system, it doesn't matter, Docker container should run by itself. And it should be simpler, lighter, and denser than VMs. Means in order to move one VM to another VM, it's like moving your server from one server to another server. It's like a virtual machine. It's a machine, comes with its own CPU, memory, static CPU, and come with its own operating system. And you're isolated with your own application. You cannot share the operating system kernel. If you have 10 VMs, 10 operating system. But now it is only one operating system, 10 containers. That's where, and portable across different environments. Now, ops guy will be very happy to say that one, that application can run in different environments, irrespective which environment I'm running, right? And this is how you think about, and when you compare with a virtual machine and a container here is, in a real world is, VM isolates the hardware, container isolates the process. Two different things. You just isolate hardware. You are dedicated CPU, dedicated memory, dedicated network interfaces. And for a process, it's not. You share across. That's the beauty of kernel. That's the beauty of containers is you share the resources. You are more efficient. I don't need hundreds of VMs. I don't need to spin up hundreds of VMs. That's a lot of maintenance works in a real world. This is at the nutshell. If anybody asks you what's the difference between VM and a container, as a technical guy, this is what you need to speak, right? It should be a VM isolation, means it's operating system plus the resources, whatever I talked about. And it's a negative about this one is you need to install complete operating system. Now you need to maintain that one like a physical server only, upgrade that one like a physical server. Only advantage you're getting here is if you crash, only you get crashed, not other VMs get crashed. But still, it is a heavyweight machine in the first place. It may be virtual, right? And it is a static compute and static memory. What do you mean by static compute? Means once I spin up a VM, I need hypervisors are the things which actually solves this problem, VMware, right? So what is the thing which I'm solving here is I need to pre-allocate memory and CPU. I can't scale up. If I want to scale up, I need to restart again, allocate the memory and CPU to that one. Once I dedicate, if I assume that one, you have 5-core machine, you have 2 gig of RAM, I can't change that one dynamically. Means I'm stuck. Whether that guy is using or not, I'm stuck with that one. He's using less, I'm lost that memory. That in the same way, high resource usage. Obviously, when you spin up a virtual box with a VM, it requires a lot of memory CPU to spin up and all. But when you talk about the containers, the benefit of this one is it's a isolation, first thing. Same thing, VM isolation. Same thing here. Now it is a containerization, shared kernel. It is not having a different kernel. It is not having a different operating system for each of the containers. And burstable computer. Very, very important point here is I can add up memory, add up CPU dynamically if I need it. And it doesn't take much time. It takes few seconds. It doesn't take minutes to change that one. Right? I can be burstable. I can spin up as many containers as possible. Scalability, burstable memory means that once I tied up with a CPU memory to a container, I can change it dynamically also with minor changes to configuration and low resource user. That's the power of containers. Very, very low consumption. Virtual machines are not portable across different environments. You can see laptop to bare metal to virtualization because you depend on that particular virtualization technologies like Hyper-V. VMware's ESXi, so KVM. So the different kinds of hypervisors exist, and that's not portable, that's not easy to manage, efficiency, and that scalability, all kinds of reliability things comes into place. Always remember, we are talking about high availability, we are talking about how efficiently I can run my data centers, my servers and all. That's where, and it doesn't provide portable packaging for application. But when you come about applications, it's all about portability, package management, and guaranteed portability across any infrastructure. You talk about a laptop, desktop, bare metal, virtualization, private cloud, public cloud, container doesn't care. Container will run as is across different environments. When you look at the Docker's images, that clearly explains this is the problem, they solved it. And they share the same kernel. That's the beauty of containers, which it solved. And this is what from traditional deployment to the virtualized deployment to the container deployment. Once upon a time, we used to do on a physical server, I used to deploy my apps, dependencies, operating system, all the necessary software to run that application, procuring the hardware. Next goes to virtualized deployment, multiple VMs on VMware revolutionized this one, multiple VMs on a single ESXi in a single hardware, like pooling the resources, putting to the VM. Now the container world has come into place. Container solves bigger problems of efficiency, memory consumption, CPU consumption, efficiency, and everything comes into place, and it can run across different platforms. Kubernetes, that's the best thing to talk about it. Now, this is what I explained. In order to talk, what is a server? It's like you own a house. You have a 3-bedroom, you have a garden, you have a swimming pool, you have a kitchen, you have all the things. You need to own it, and you need to maintain it, and you need to keep on repairing it if something goes wrong, and everything comes with the money, and you can't replace it. If you don't like it, you can't go it. You need to sell it out and move on. Right? This is how you need to think when you think about a server. It has an address, it has a name, and there is no shared kind of things. It's you who owns this one. It is you who maintains this one. Everything, cost, maintenance, everything comes into place. And time to time, upgrade, cleaning up, all the things, refurbishing and all those things. When you think about a container, you're actually looking at like a apartment in a house. You share the lobby, you share the elevator, you share the swimming pool, you share the guest room, you share all the conference room, anything means that you're living isolated, but still you share the common resources, but you do what you do what you want to do in your home. But when you go with the shared resources, see in the same building, I can have 100 apartments, 100 families can live in this one very efficiently. I don't need to own the entire building. I don't need to own the swimming pool. I don't need to own common areas, which I can get it in a shared basis, but being nice to play around. That's what containers analogy in a nutshell. And this is on a technical point of view, very inefficient use of memory and CPU resource. You think about the diagram, this is clearly says that I have this many servers and every server is dedicated with only one application. I can't reuse. If that application is not using memory and CPU, I can't reuse it for other application because of obvious reasons. If one application crashes, it should not crash the other application. So databases, web servers, everybody needs their own servers, and it's a cost to the company. When you talk about hundreds and hundreds of servers, it is very, very cost to the company to hold one application, one server. That was there before Docker, before containers, but now the world has changed. I want to be isolated, means I want to be self-dependent. I need to come with my own baggages, dependencies, operating system related stuff with me, what I needed as an application, and I can coexist with other people. Think about how much money at the top level you can save. Billions of containers. If Google was not innovated on those containers in terms of distributed systems, C groups and all those things, think about you should have billion servers, billion VMs, and that's humanly impossible to create that one. Just because of they contributed the C groups and namespaces to the Linux kernel, that's why we are taking the benefits of Docker. Containers were there for a long time, but that was very difficult to handle, right? And very difficult to maintain on the Unix side, but Docker made it very easy for developers. So at a technical level, right, so what are containers here in the sense which I was talking about is it has its own Linux, tiny Linux VM. Let's put it that way. Plus your app, plus your dependencies, that becomes your container. When I say namespaces means, think about it's a tiny operating system, mini operating system, nothing fancy here. Mini operating system means, what does mini operating system will look like is, it should have its own PID. It's a process ID. It has its own root init thing. It has its own user IDs and everything what you configure like in a regular Linux operating system, you're doing for the container itself. And UTS for host names, domain names. It acts like a mini operating system plus your application. End of the day, your application, what does it need? Your application, dependencies, configuration things, ports, whatever it is, and it needs some Linux operating system to run in our use case. So what does Linux operating system consist of? PID to user to networking. Definitely you need a networking. You need an IPC for communication stuff. You need a C groups which manage the resources and all for the Docker point of view. And that's what C groups come into place, used for sharing the resources, available resources, and setting up the limits, CPU and memory. And union file system, that is how it can make up multiple layers. If you install many packages, it will add up to the multiple layers and create a Docker image for you. And that's how the container runs for you, that one. So let's look at the smallest example. As I told, I want to show the very, very, very important example for this one is, how do I restrict resources? As I told, it's all about restricting resources. Irrespective of what I do, I need to restrict resources for my containers. How do I Docker do? If I restrict my resources to the containers, lab 14, C groups, as I told. So these are the qualities of my C groups as a control groups, part of the Linux kernel. And if I want to max out 2 CPUs, I can do that one. If my process needs out of 10 CPUs, I can ensure that one, as I told, I can limit my CPU and memory for a container. That's the best part of Docker here is containing that limits. And internally, Docker uses that characteristics of Linux kernel, C groups offers, and builds the containers with the limits on that one. Let me show you two use cases just to have an understanding. I want to ensure that previously I didn't have this option. When I install my Redis on my operating system through package management or sources, it will run Wild West. If I increase the load, it will occupy CPU and memory for that one. I cannot control that one. It depends on the load. Now I can restrict that one. This is how I avoid then crashes. So max out 2 CPUs, right? So there is a stressor example. I'm going to run the stressor to show you how these things run, right? HTOP, which I already run it. This labs, just it is already there. You can look at that one. I cloned this repo already, and it just shows the file here. The file is nothing but there is a tool called a stressor. What the stressor will do is actually stress the CPUs to the maximum load. But with C groups, I can stress a couple of cores. I'll show you how to do that one. That's all it does. It's a stressor tool, and I'm using a Docker file to use the tool, and I'm running that container. That's all. The stress is a container tool, which job is to run some process across these 2 cores. I'm just running that one. This is build and everything I've done. So let me go to the directory. I have already that directory, CD labs in my local. So let me clear this one. These are 2 takeaways for this session is, how do I C groups works, right? So go to the directory then, which is the directory is talking about, CD labs, because I already showed it, right? CPU stressor. Then he's talking about cat Docker file. That's okay. It's only, as I told, it's only one file. Stressor, it's just a utility file. I'm just making it as a container. That's perfectly fine. He asked me to build it. That's fine. I built it already. Just to showcase how the Docker is working, how is building, because it's Linux tool, but I'm containerizing it. That's so I just built the container now. I want to run the container. What is the goal here? I want to max out 2 CPUs. I want to just use 2 cores. I will never ever touch other people's thing. My goal here is to occupy. How do I validate that one? I'll run this htop command. And you can see here, just I ran that container, nothing fancy, just a tool. And see, now you can see at any point of time, I am occupying one or any particular, this is what htop command, it's like a task manager. It shows up the CPUs, memories, what kind of process is running. If you see 1, 2, 3, 4, my machine, my laptop is a 4-core machine, and I have a 7 gig of RAM. And I'm ensuring that at any point of time, 2 cores should be dedicated for this particular process. I'm ensuring that one means that this particular process, your application, I used to give the example, right? CEO, CTO, a junior engineer. CEO has high preference. If his application, he wants to run his application, obviously in the company, his application is more critical than a CTO's application or a junior program's application. So at any point of time, CEO's code should not fail. Junior programmer, it's okay, he can fail, that's okay, but he has a less priority compared to CEO or a CTO. So this is how I can allocate resources for CEO at any point of time. He should be dedicated to cores, irrespective, because his application, his business is more important than junior programmer's application. So junior programmer will never ever take away CEO's CPU, because that is what I made a contract with using Docker C groups and Linux kernels feature C groups and namespaces. Now, that's the one use case. Now, as a good citizen, that's what it shows. That's the use case where I'm pinning out CPU and memory to the priority, any process which I talk about. Previously, this was not there before Docker era. Anybody can do Wild Wild West. Anybody can crash anybody's system. Now, I'm going to stop that one. This is the regular command, which stops this one. Right? So it stops. Now, you can see htop dynamically reacting to that one. As I told, this is very, very CPU memory conscious things, because this is a stressor is very effective in those consuming the loads. And I want affinity. This one small example. I have written clear documentation is there just to get a high-level view how to set CPU and memory limits through C groups. That's the goal here. Now you see, I'm back to my original condition, what I was there. Now what I'm doing here is I'm setting out stressor for a particular CPU. I'm not assigning 2 random CPUs, but I don't want to jump across random CPUs, but please dedicate me 1 CPU, because there is a context switch. It takes a lot of time to context switch and all performance. These are performance intensive applications. Here, when I say 0 here means actually it counts like a C thing. So 0, 1, 2, 3. Here in htop, it shows 1, 2, 3, 4 cores, but actually you should talk, when it talks to Linux kernel, you should talk in terms of 0, 1, 2, 3. So here 0 means it's the first core of the machine. Now you can see my CEO is always dedicated to that particular core. Now you can think about your applications, mission critical applications will be dedicated to that particular CPU only, or a group of CPUs. You can have even shares. You have 50%, you have 25%, 25%. That's also is happening. That can also you can do with the C groups. That's the beauty of C groups. That is how Google containers are running. That is how high available systems like Google Gmail or Google search engine or YouTube are highly available because of these reasons, because they pin out resources to those applications so that they don't crash or they don't take away somebody's resources. And that's the best part of C groups. That's the contribution from the Google. Now, again, as a good citizen, I will go and close that one, right? So I'm going to stop this process. Now, how do I have a small script? That's nothing fancy here. I just stop that one and make sure that it stops my containers. That's the only thing. It just removes the container, stops and removes the container, right? Now, CPU share constraints also, right? 5 junior programmers are there. Everybody is equal to me. I can assign 25% to CPUs for those junior programmers. Think about those are low-level processes when I say that one, right? CEO dedicated for 50% of the CPU, whatever the resources I have, and CTO 25%, and rest of the juniors can have 25%, whatever, however you can allocate. That is what sharing the constraint. You can say here, I can share the CPUs also in the terms of how much CPU I can share across the percentage of CPU, 50%, 25%, 35%, instead of dedicating whole 100% to one core. This is the same command, but it shows the what do you call percentage of usages. That's very, very important to understand. It's all about understanding how the things are working. Now, this is what the memory thing. I can even restrict memory in the Docker. right? Through Docker implements C groups things inside. So I can restrict particular Nginx process 512 MB. Just don't go beyond this one. If you go beyond this one, please kill me. That's it. If you go beyond that one, so that's the way memory reservation also I can do it. Means that minimum it should be this one, maximum this much one. So if anytime I overtake somebody's one, operating system will come and kill you. So that is how you manage multiple processes by using C groups and namespaces by restricting the resources. And that's the biggest example which I want to share with the C groups and namespaces. Max out 2 CPUs, set the CPU affinity and CPU share constraints. Blog is GitHub is there. You can take a look on that one. Every step by step I shared with you. At a high level, this is what the C groups looks like. RAM, CPU, network, IO, these are the resources. Before Docker, everybody can use these resources and crash the system. Now with the Docker, I'm restricting the resources for every application with the percentage, with the number of cores, with the memory, all the resources. And C groups helps in achieving that one. Now, when you look at the CPU namespaces, this is what you need to look when you, like an engineer, you need to look what a container will look like. Means it's an Nginx container. It has a mount space, host name, PID, network, IPC. That's like a Linux operating system only, but you have Docker helping in creating that minute Linux operating system for you, right? So that's one thing. That's the infrastructure things which I want to share. So this is workloads, apps. You can think about websites. You can think about workers, CRP, CRM products, right? Front-end products, queue, messaging queue products, analytics, and all those things running in different platforms, like development VM, QA server, production server, public cloud, private cloud. Think about how much configurations it's painful for a developer to install these applications. To build these applications, first pain, ops guy to run this application seamlessly across this environment, right? Because of configuration diff, changes in the environment, changes in the operating system upgrades, and that becomes a matrix of hell. In the sense, I have applications on the left-hand side, on the right-hand side, on the x-axis, on the y-axis, I have all my different kinds of hardwares, configurations, laptop to QA server, to dev server, to the staging server, pre-pod, and developer has always the problem. I don't know how the dev server, how the production server looks like. That configuration is totally different. I can't reproduce the same issue. He always says, it works on my machine. QA machine, I don't know how it works. I don't know what is the configuration it works. Now, Docker solves the problem, right? You put it in a container. You come with your baggage, package dependencies, you come with your application. I'm here to package your application. Like you can think about raw products, like you can have boxes, cars, any kind of shipping, oil, anything you think about it, end of the day, it fits into container. That's the contract. I don't know what is a product looks like outside. You get your products. If it's an oil, tell me it's an oil. If it is a gas, you tell me it's a gas. It's your product. Only the destination guy should be validating that one, not me. My job is to just to package this one. Internally, container shape is always the same. You put horses, you put cars, you put bikes, you put rice, you put whatever ingredients you want. Container doesn't care. It's your stuff. When I come to the target destination, my job is to move from X to Y to Z. Target container will be always go like a container, shipping container. That's the reason they use that example. I isolate. My job is to move from this to this. Doesn't matter which environment. Target environment, you want to dispose these containers in a truck, in a lorry, in a bus, wherever you want to put it, your containers in a train or any kind of places, it will be the same. Your destination guy, when he opens up where it runs, it will be running the same thing in the destinations. It will be the same. Now you see container across different environments, across different applications, it will be the same container across environments. Moving, that's where container solves the problem. And this is what I always advise people to look at these places. If you want to look up reliability, stability, how the open source should look like, and where you can learn and motivate, this is the place I always advise. Go and look at this Free Software Foundation. This is where the Linux was born, right? And this is a Linux kernel org. That is where I go and motivate myself, real engineers, top-notch engineers on the planet Earth, contributing this one. And Google, Facebook, Netflix, Amazon, any company you take exists because of Linux, without any question. Because behind the scenes, if Linux kernel is not there, this company doesn't even exist in the first place. So everybody is behind Linux kernel. And these Linux kernels makes innovation happen from a Docker to Kubernetes, you know, anything, any data science, any IoT, everything runs behind the Linux. I'm very, very hardcore Linux nerd in that one. So whatever is, that's what I was working on. That's the products I work on. And I learn from these places, understanding about Linux for motivating myself so that I can better understand the internals. Whenever there is a problem, I had to go to the down level. See, I went up to the CPU memory level to deal with this one. In production, I had to deal with millions of containers. If I want to troubleshoot something, I need to know what is happening with the container. I can't say Docker will take care of those things. I need to troubleshoot. I need to understand monitoring. I need to understand everything. First of all, I need to understand internals, how the things are happening. How do I set the memory limits? How do I set the CPU limits? By understanding what is happening in the production. Where do I troubleshoot it? By understanding Linux kernel. End of the day, it has to come and run on the Linux kernel. However abstraction you make, end of the day, it's a process for a Linux kernel. So this is where I go and motivate. I keep on learning these things from a technology perspective. That's the session. Now I want to share something about DevOps Artisan, right? So this is one of the finest things about the courses which I heard, built by true DevOps engineers. I met a couple of people, and they are true to the core engineering. And these are the courses which I met with them in one of the courses like that only. These are the courses like AIOps, analytics. They have everything related to DevOps. I didn't find anywhere where a particular agency or particular institute or particular company who just focuses on DevOps. Right? I see all the a la carte of products, Azure to Microsoft to and AWS to Google to every kind of product, and everybody's talking about data science. All are scattered across. But here I get to everything related to DevOps, whether it's a DevOps, site reliability engineering, performance things, Ansible to Chef to whatever the tools, messaging, monitoring platforms. And this clearly implies that it's all shop for my DevOps related things. If I want to become a DevOps engineer, this is the best place to go look at least to know what is happening in the DevOps world. And I can see the engineers putting a lot of effort. I've seen their videos. I met with a couple of focus. They are very core to the engineering principles. That is what I don't want to hear theoretical stuff, which I can read in YouTube or on a blogs or something. I need to look at real engineering problems. What is the problems you're solving using a specific set of DevOps tools? I prefer DevOps Artisan on those scenarios. And there is offering of certification also. They recently started with this one. One is on release engineering. I never seen anywhere people talking about release engineering. I have done my own release engineering. My own company offers those projects. I had to build my own release engineer platforms, build systems or anything from the scratch. I had to learn from open source. I had to build from into my company. But there is nobody teaching me what is a release engineering. I think they have this R1001 certifications, and these are available through Pearson U. That's what I heard from. So that's a well-known certification agency who can provide you online certification. And they put together a lot of effort in getting this release engineering. Automation, obviously everybody loves automation, but where to go for automation? Everybody talks different terminologies, different technologies, and it's a hell lot of technologies outside there. But getting it one shot, what is the flow of 0 to 100? That I don't get it. So that's one of the things which very good offering about release engineering certifications through Pearson U. So that's one of the certifications. I never seen a private agency getting that certification. Only AWS or Google or big companies offering those certifications through Pearson U. And they'll be releasing. This is the associate level. So if I remember correctly, that's what I learned from them. So professional certification, real production. How do you solve production issues? How do you learn from the engineers who are actually working in real industry like me, sharing their experiences? That is what is all about these certification courses, what I learned from them. And I have seen people giving an excellent education about real technical problems happening in productions, happening in real world, not a theoretical thing. This is how you use it. This is how you try it out. So those are two nutshell, and that's my training. Thank you for your time, guys. So I appreciate everybody's time. This can be more. I have much more examples to showcase. Actually, that could be the next sessions. But this was focused, as I was telling, this was focused only on the low-level things, C groups, namespaces, how Docker helps utilizing those things to pin those resources for processes, and how Docker was evolved from the sources, from the apt-get to the how Docker solves the platform or a platform as a service. You heard of infrastructure as a service. You heard of like AWS or Google or Azure, and you heard of software as a service like a Gmail or a Salesforce. But platform as a service is a very tricky thing. Where can I think about? This is the Docker Hub is a platform as a service, and that's where I can serve my applications to outside world. It can be private. It's like a repository for your applications, but those are Docker related applications. That's from my side. Thank you for very much. If you have any questions, guys, I took extra time.
Thank you, Narendra. It's okay. Yeah. We are in time. We have a question.
Yeah.
In the Q&A box.
Let me see it. Yeah. Can you repeat the question?
Yeah.
Because I'm scrolling a lot of things. Yeah.
Alexander asks us, what about security? Keeping in mind latest news about zero-day exploits.
Okay, so security, Docker doesn't come with the security in hand. You have to implement your own app capabilities. There is a Docker primitives for those things, and there are some best practices. So Docker offers root. Whenever you launch anything, it is like I'll run this one. It is like a root thing only. Run -it. It's a busy box. If I want to run busy box, that's a container, right? So busy box, if I want to run, if it is a bash, let me see it. So it doesn't have any bash, so it has a shell. Let's assume. Yeah, it has a shell. So this is the Linux operating system. So you are a root here. So you have to enable those security related options, like don't allow your file system to be read-write. You can enable through RO parameter. There are some Docker primitives where you can enable your file system, which you mount from your host system to the Docker container, only read-only, first thing. And avoid set UIDs, set GIDs, and set group IDs and all those things. There are some best practice and app armor, security capabilities, those things you need to enable. Docker is a wild west. It gives you everything, but you need to restrict those things in your Docker file or through command line. Yes. And next question, Elena. Hope that answers the question. Docker is giving you full. You need to take care of the security. Security is not default. Docker solves only about the C groups, the pinning of the resources, container package management. Those are the strict things it solves the problem. Rest of things it leaves to the user. It provides the primitives for putting those security related thing in your. That's what base image. Base image I was talking about. Base image. Base image is the thing which you build your application on. Right, so you need to ensure that base image has been tested. There are some tools called as CVO tools, and Quay, and Quay is one of the Docker registries actually. And Docker company itself validates, runs vulnerabilities on your Docker container, Docker images at runtime. That is what you need to pay for those services. And container registries like Azure Container Registry, Amazon Container Registry, in production for Kubernetes, like Google Container Registry. They will run the tools for you, and you need to watch for those images. So don't trust for random images. You need to validate. And there is a tool called as a dive actually. This tool, this will help you out to look for security loopholes inside those images. That's how you validate what kind of file, what kind of process it is running inside the base images. Any question? Next question, Elena? Hope that answers the question. Yeah.
That's it.
That's it. Oh, okay. One question. So I can talk about security more then. Okay, I had some questions. Yeah. Okay. So if people have any questions, I'm happy to help. You can send an email. I'm happy to respond to those questions, and I can work with Elena and team to respond to those questions. I'm happy to talk about much on Docker. So this is only a tip of iceberg to start with. That's it. There are a lot of things about how to use a Docker that anybody can learn. There are a lot of tools available. There are a lot of tutorials, YouTube videos, but this is what is not available on the internet. How to start with what kind of problems you're solving. That is what my stress is, about what problem Docker solves. And I think I'll be blessed. The problems which I was going through for a long time, Docker has solved it. Similar thing, other people would have had the same experiences. Thank you for time, guys. Thank you very much.